Hello, good evening. Hope you can hear me. If the audio is okay, you can just raise your hand. Okay, that is one. Okay, two, awesome. Okay, so let's give like 2 minutes, then we get started. See if there are people who gonna join. Yeah. Just 1 minute and then we get started. Okay, so I think we can now get started. So today's topic is an amazing topic, and I really like it because this is what actually what makes blockchain even more secure and also more interesting. Like this is what makes it decentralized. Yeah. So it's called blockchain consensus mechanism. Almost people call it consensus mechanism. So it's a continuation of what we did with the Celo protocol. Now we want to look at the different protocols that we do have for consensus mechanism, like coming up to an agreement. Remember we said that blockchain is decentralized with different nodes connecting into the blockchain. So how do they connect? What kind of protocol do they use to actually communicate and to validate these transactions? So that's what we're gonna look at today. So I hope my voice is okay. Just a thumbs up.
Yeah.
Okay. Awesome. So today's agenda or today's topic will talk more about what is consensus mechanism, the two major consensus mechanism that we all know. So we're gonna look at the difference between proof of work and proof of stake. And we're also gonna see the different, the other types of consensus mechanism. So proof of stake has delegated proof of stake. We also have benzenite generals problem, the one that I told you guys to look at. So today we're gonna look at it into detail and see how the benzenite generals problem, what it really is, and the problem that it solves in when it comes to blockchain, and especially in computer science and that. Then we also have the practical benzenite fault tolerance, PFBFT, which comes from the benzenites general. So from Celo protocol, we saw that we have the benzenite fault tolerance in proof of stake, like inside the blockchain protocol, and the consensus mechanism being used being the proof of stake. So we're gonna see how this thing relate to each other and how they differ from each other. So yeah, I think if I may, somebody may at least give us like an idea on how what they do understand by consensus mechanism. If anybody has an idea what consensus mechanism is, you can type on the chat, and then yeah. You can type on the chat and say what do you, maybe if you have an idea of what consensus mechanism is, or yeah, okay. So if nobody has an idea of a consensus mechanism, then I think we can continue. We can get started. So, okay, so Masaku is saying some kind of a memorandum. Yeah, it's something that people do come together and agree upon. There is rules, of course. Yeah. Anyone else? Anybody? Anyone else? Memorandum. Yeah, there is rules. So in a consensus, there must be rule. A corrective of agreement. Awesome. Corrective of agreement. Anyone else? Yeah, they have to. You have to like agree upon some a lot of rules and behavior, like how do nodes have to, like how do people act. So I'm gonna simplify what consensus mechanism is. So you see the group of friends that you have, or the work, the company that you have, or the company that you are employed to, they have a consensus mechanism, how they agree or how they collectively come up with a way that we should fire this particular employee, we should do this with the money, the profits that we get. They have a kind of an understanding that this is how we are supposed to run the company. So that is basically the same case. So when it comes to blockchain, consensus mechanism is a fault-tolerant mechanism that is used in computer and blockchain system to achieve the necessary agreement on a single data value or on a single state of the network among distributed processes or multi-agent systems such as cryptocurrencies. So this mechanism allows the system to, or the blockchain to work in a way that it doesn't break or it has to continue. If a particular system fails, then the system continues to work. So it's very useful for in record keeping, among other things, like to prevent double spending, and also to make sure that the system remains strong. So there are different kinds of consensus mechanism algorithms which work on different principles. So there are two. The most popular ones are proof of work and proof of stake. Proof of work is abbreviated as POW, and proof of stake is abbreviated as proof of all POS. So you may find people saying POS or POW. So POW is proof of work, and POS is proof of work. So these mechanisms are very important when it comes to deliberating and coming to an agreement that this is what is supposed to happen. So some demand you to show you are working, some demand you stake. So we're gonna first of all start with proof of work consensus mechanism. And proof of work is a common consensus algorithm used by the most popular cryptocurrency network, that is Bitcoin and Litecoin, and also Ethereum. Ethereum uses proof of work. So it requires all the participant node to prove that the work done and submitted by them codifies them to receive the right to add new transaction to the blockchain. So let's go back to the scenario for an office. Everybody or the company agrees that for you to add or for you to be paid, you must validate how you have come to this conclusion. Like you must prove that you have worked. You must prove that you have worked so that they can be able to pay you the allowances, not the allowance, but your salary. If you work extra hard, then you get bonuses. So that is proof of work. So it requires all the participant node to prove that the work done and submitted by them qualifies them to receive the right to add a new transaction to the blockchain. Now, for this particular case in blockchain, it means that once you have validated that the data or how you have come to a conclusion that this is valid, then you are given the right to add a new transaction to the block. However, this whole mining mechanism of Bitcoin needs high energy consumption and longer processing time. So the more there is a difficulty level, of which we're gonna talk more on a tutorial that we're gonna do. I think next week is when we're gonna be starting a little bit on coding. So you're gonna see the difficulty level. So there is a difficulty level, and every time you do a validation, the difficulty continues to increase. Now think of the way I like to simplify it in a very simple manner. Now, there is calculus, there is algebra, there is quadratic equations, and especially quadratic equations. So the quadratic equations starts very simple. They start very simple. You can do the quadratic equation, the very simple ones, without even looking at them. But as you advance using different formulas and different methods to calculate, it becomes even harder to actually do that. It becomes even hard for you to do that. So as the calculation becomes so complex, you require a lot of time to do that calculation to prove that this is how you have arrived to your answer. So the same case for proof of work. So the difficulty level continues, meaning that you will require more time and also energy to perform that calculation. So that is the major shortcoming of proof of work. So this is actually how it looks like. So we have a miner, and then we have a block, and then we have the block puzzle. So this is what they solve, and they show how they have come to this conclusion. So every time a new puzzle becomes even hard for them to validate, or the machine to validate. That's why you have to like pay more for your transactions to be validated, because the miners are losing a lot of energy and such. Then you have to prove how you have come to that calculation, and then they broadcast the new block. But before they broadcast, they have to show that this is how I came to this answer. Just the same way we used to do when we did mathematics or we did calculation in class. So we would, the lecturer would ask, how have you arrived to your answer? So, and then you have to show your workings to the entire class that this is how I did my calculation, and this and this, and this is how I arrived to my answer. So all the other miners agree that this answer is correct, and then they are able now to broadcast. They are able now to broadcast the new block, and also the other miners are able to verify that this answer is correct. So the more you have more verification on a block, the more it becomes valid. So the more when everybody says that this answer is correct, it becomes valid and nobody can be able to dispute it later on. Then the process starts all over again. Yeah. So let me show you a transaction in Ethereum, because Ethereum is the one that uses proof of work. Okay. Let's just use a particular token. So this is the transaction hash. Okay, yeah. So this is the block confirmation that I'm talking about. So as you can see, it has a lot of block confirmation. It's a big number, but the more confirmation that you get in a particular transaction, it means that this transaction is valid. It's a valid transaction. It's a valid transaction. So this is why you need to do the mathematical puzzle, and then you get paid in form of gas fee. So you get this gas fee. This gas fee is what the miners get, and also they also get transaction fee. They also get transaction fee. So that's on the verification and confirmation, or confirmation by miners. So the more blocks you have, the more valid the transaction becomes. But if the miners don't agree that the answer is correct, then it becomes a disputed block. A block that has, let me show you. Invalid blocks. So it becomes, there is disputed blocks, and there is also invalid block, such as, so a miner can create an invalid block in many ways, such as putting an invalid timestamp on it, also including having invalid transaction in their block. So you can read more about the invalid blocks. So this is a block. A transaction contains the transaction hash, a status, a block, and also a timestamp. So a miner can try to invalidate a transaction by adding invalid timestamps. But then again, all the other miners have to agree upon. So if the timestamp is not valid and it doesn't follow, then the transaction becomes invalid. So you can actually read more about this invalid block and what happens to the valid transaction in that block. So if there is a valid transaction, what actually happens to it. So that is on proof of work. Then we have the second one, which is also a major consensus protocol. So you will hear people talk about proof of stake, or delegated proof of stake. Yeah. So proof of stake, or POS concept, states that a person can mine or validate block transaction according to how many coins they hold. So anybody can be able to become a validator or a miner in POS if you have staked certain number of coins. So this means that the more coins owned by a miner, the more mining power they have. But still, this is a problem. If you have a lot of coins, it means that the network, you can control the 50% the 50%, and you can perform the 50%, the 51% attack on the blockchain. So there is other concept like the Byzantine fault tolerant, which has been added onto the Celo blockchain so that it can be able to prevent different users or different miners having a lot of coins and then performing or having a lot of power on the blockchain and then invalidating the blockchain or making the blockchain invalid. So there are some I'm not really sure, but there is something that happened to this network. EOS yeah, this is what actually happened to EOS. So EOS didn't have a lot of validators. So there is a number of validators that you need so that your system can have your blockchain can be able to control the majority of hashing power. Like it has a lot of, it can be able to. So that's what happened to EOS. Yeah. So you can search more about EOS. This one, can EOS be, and it actually happened. So that's why some of this blockchain has been really hard to come back or to actually maintain their flow. So this is actually what you really look when you're building. If you're a developer and you want to build on top of different blockchain, this is what you really look at. So you have to look at the number of validators they have, the number of the vulnerabilities the system has had, and yeah. So these are some of the protocol the blockchain is using. So these are some of the things that you have to look at. So blockchain suffered the 51% attack because they didn't have a lot of node validators or miners. So the same thing when it also, if you want to pass something in the parliament, the same consensus mechanism that works in parliament, you have to vote. And if you have a lot of majority voters being malicious, then the system becomes vulnerable. Yeah. So this is also a problem. The more the miners can have more mining power, and they can perform the 51% attack. So the proof of stake was created as an alternative to the proof of work concept to tackle inherent issues in the data. So currently, only altcoins use the proof of stake concept. Bitcoin is yet to do, but I don't know. People have argued if Bitcoin moves into proof of stake, would people still have trust in it? Don't know. I don't know. But it's something which a lot of people have been debating about whether to move Bitcoin to proof of stake so that it reduces the energy consumption. So when a transaction is initiated, the transaction data is fitted into a block with a maximum capacity of 1 megabyte and then duplicated across multiple computers or nodes on the network. So the nodes are the administrative body of the blockchain and verify the legitimacy of the transaction in each blockchain. So is there any question up to there before all I've lost you guys. I'm more alone in this space. Hello, have I lost anyone? Yes. Yes. Iduo.
Hello.
Yes, I can hear you. Okay. You can ask a question if I have lost you. You can always say that I'm lost, so that we
No,
get it right.
I'm just joining, so I don't really have a question for now.
Oh, okay. Okay. So anyone who joined early, who has a question? If you're drifting in space, we are heading to the moon. So we can always come back for you and we move together. Yes, Potent.
Maybe I'm asking an irrelevant question. So if the proof of stake method as well as the proof of work still has mining as a way of sourcing the coin, then what makes the proof of stake better in terms of energy saving?
Okay, in terms of energy saving, you see the proof of stake requires you to stake your coins for validating transaction. And the next slide was going to explain actually how if you do misbehave, or if you do misbehave and if you own like 51% of power, then you have your chances of losing those coins at stake. That's why it's called proof of stake, because you stake your coins, and if you do a malicious intent in validating the transaction, you can be able to lose your coins. So here you don't have to perform any calculations. So like in class, we go back to the example of the classroom again with mathematics. So mathematics, you are proving that you yes, Emmanuel.
I want to ask a question. What is the difference between proof of stake and this decentralized proof of stake?
Delegated proof of stake.
Yes,
Okay.
delegated, yes.
Yeah, we're gonna get there in the next two slides. So let me just finish up on Potent. So like I was saying, Potent is that we go back to the example of the classroom. There are people who would stake their marks, their results. So once they have been able to once they have the exams they have done, the exams the student have done, they can be provided with their results early enough. So somebody knows that I have 100% in my mathematics. So the teacher can decide, if you want to pass in my class, I just give you all in the moment, all at the same time, like in the beginning of the term or in the beginning of the course. I'm gonna give you 100 marks, all of you. Now, whoever fails in my class, whoever fails in my class will get a deduction of like 1 mark every fail they get. Like if you fail today's lesson, if you fail today's lesson, you lose 1 mark. So you will have the chance to actually work more. You will have the chance to actually validate a good transaction. You will have to work extra hard so that you don't have to fail in your so that you don't get deducted. So in that way, it will and then you get incentivized for good behavior as a miner and as a validator. But in proof of work, you have to buy specific machines. So anybody who doesn't have good machines, or anybody in the class who does not know how to calculate quadratic equation, definitely they will be exempted out of the class, because they are not good in solving, or they don't know how to prove how they have been able to work. So in this in proof of work, you use a lot of energy and you use a lot of power, because those links have to be online every hour. They have to be online, and you have to, the CPU actually uses a lot of energy when doing the calculations. So you realize that with proof of work, you need a lot of machines, you need high computing power. But in proof of stake, you just take your coins. You don't have any, with your phone, actually with your phone, with your machine, you can stake your coins. I'm gonna show you don't know whether it's gonna make my machine. I've got it a bit, but there is it's called Celo Wallet. So Celo Wallet is a desktop wallet that allows you to stake. So I'm gonna just wait for it as it waits. I hope I have answered your question, Potent. Okay, Diram, you have a question?
Okay, I have a question. So you say you're not sure when Bitcoin uses proof of stake, you don't know, you're not sure if the owners will
Yes.
trust it. You say,
Yeah.
you said that you're not sure if when Bitcoin uses proof of stake, if the owners will trust it. So why does the trust it?
I can't hear you clearly. Maybe you can type all. Yeah, I can't hear you clearly. Hello.
Can you hear me now?
Yeah,
Can
now I
hear
can
me?
hear you. Yeah, now I can hear you.
I was asking, you said you're not sure if when Bitcoin uses proof of stake, you're not sure if the owners will trust this mechanism. So why does the trust issue have to come in?
Okay, it's a debate which has gone there, which has been there for a while, because there is some improvement Bitcoin did. There's some improvement Bitcoin did. It's called the carrot. Yeah, carrot. Is it carrot or yeah, carrot improvement? And it's so apparently Bitcoin does not the taproot. Yeah, taproot. Yeah, it's taproot of carrot. Taproot. Bitcoin. Yeah. So funny thing, or not funny thing, but something interesting is that Bitcoin didn't have Bitcoin does not support smart contract development, and Ethereum has support for smart contracts. So creating or proposing such kind of change like proof of stake is a question that most people have, because currently most people have trusted Bitcoin, and with change people tend to lose trust, and with the majority of the Bitcoin holders being organization and the federal government, the US government, that's what makes the question for moving to proof of stake or to proof of work, to moving from proof of work to proof of stake, makes people to have questions like, will it still work the same? Will the method still work the same? But for me, I believe I will believe in Bitcoin even if it moves to proof of stake, because Ethereum is moving to proof of stake, and transaction fee will actually slow down. No, transaction or gas fee will reduce exponentially, making Ethereum very fast. And I don't know whether I should do this radical prediction or something, but I believe Ethereum someday or sometime, maybe 2 to 3 years, it will overtake Bitcoin in a way once the gas fee have been reduced. Because one, a lot of developers are in Ethereum and a lot of products are in Ethereum. And if Ethereum does make a major milestone or breaks a major milestone, then everybody or the other guys are able to follow along the Ethereum. So there is that question. If the move to proof of stake for both protocols, Ethereum and Bitcoin, will create trust, or will it be able to onboard more people onto the network? Will it be with that? Yeah. But it's something which I believe, because other blockchain like Polkadot and Solana have been able to overtake blockchains like EOS, like Eternity. They have been able to overtake, and Eternity and EOS have been there for a while. Yeah. So proof of stake actually have promising after effects, which are really good in a way. Yeah. So it's something which I think it's gonna be able to create a lot of trust, because more people will be able to actually join blockchain as validators and as miners and as validators. Yeah. So, but then there is that other question on what do we call it? Gold. So gold is still variable, even if it changes its form, it's still variable. So the same case will be for gold. So you can read more about the Bitcoin taproot and those debates which are they are online. Yeah. So yeah, I hope I have answered your question, even though it's in bits.
Yeah, got it. Yeah.
So I've been able to open so just give me a minute. I input my password so that I can show you the Celo desktop wallet. Celo wallet. Okay. Okay. I didn't want to show you this, but okay. So so this is hope you can see my screen. Hello. 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 Hello.
Yes, we can.
Okay. So this is the staking, the Celo wallet staking, and this is the total number of the groups of people who have been able. So Figment Networks is a Polychain is also part of it. A group of different people who have done staking, and you can see. So let me see if we click onto this. You can be able to vote for this group. So they propose different proposals, and then you can be able to vote for them through your coins. So in a way, you delegate power. You delegate power to a specific node. If you don't have a lot of coins, you join together with a group or like an administrator or a delegated a delegate who has a lot of power, a lot of coins, and then you vote for the group, and then they are able to stake for you. Just like what happens in shareholding companies. So there are people who owns the majority shares, and you only have like one share, and you want to vote for a specific change in the company or in the organization. So you join those who have the higher percentage of shares in your company, and then you are able to vote on a specific change or a specific improvement in the company, or even in a change of directors or something. So that's how actually proof of or delegated proof of stake work. Yeah. So then, yeah, so we continue on the proof of stake. So to carry out the verification step, the node or miners would need to solve a computational puzzle known as the proof of work problem. So that is in proof of work. So miners have to solve that computational puzzle. So the first miner to decrypt each block transaction, like I said in the example of the class, the first person to solve the quadratic equation, the lecture has said that they will give a reward. So they get rewarded with a coin. Once a block of transaction has been verified, it is added to the blockchain and a public transparent ledger. But it's different from that in proof of stake. So proof of stake seeks to address this issue by attributing mining power to the proportion of coins held by a miner. So this way, instead of utilizing energy to answer the power proof of work puzzle, a POS miner is limited to mining a percentage of the transaction that is relative of their ownership stake. So for instance, a miner who owns 3% of the coins available can theoretically mine only 3% of the blocks. So if you have like 3% of 3%, the same case in shareholding power. If you have 1%, when dividends come in a company, stake, if you have 1% share in a company and dividend comes, then you will be given 1% of the profit share. So the same case for miners. So if you have one coin or three, if you want 3% of the blockchain, of the coins, not blockchain, but coins, and you have staked them, you can only be able to mine 3% of the blocks. So you don't have to mine all the blocks. But in the proof of work, the miner has to mine every block. They have to mine everything. So this is also what results into a lot of power consumption. So you see, this actually makes you make it easier for you. So if you mine 3% of what you have staked, then it means that you will be able to mine. If you mine 3%, then you'll be given another 3%. You'll be given another 3%. You don't have to mine every transaction in the blockchain. So this actually reduces in the power consumption. So we have incentives and disincentives. So this is what I was talking about, people who act maliciously. So as a way to keep validators from acting maliciously or adding fraudulent transactions, so like we've seen, there are people who can be able to stake a lot of coins, and the sharks, they can have a lot of coins. But to prevent them from acting maliciously, there is what we have incentives and disincentives. So the total value of token stakes needs to exceed the transaction fee and so for you to be a validator, so that you have a lot of stake to lose, you have to stake more than the transaction fee that you will be able to earn. So let's say the transaction fee is 100 bob, then I have to stake 200 coins, so that if I act maliciously, I'm at the stake of losing 200 bob. So I won't be able to invalidate the transaction or do malicious transaction in the blockchain, because I'm at the stake of losing 200. So 200 is more than 100. So yeah, if fraudulent activities is detected, the validator loses their stake and will not be allowed to participate in the validation process in the future. So this is why larger stakes are favored since the validator stands to lose more from acting maliciously. So this system helps create trust between the respective parties. So this is a good way, rather than investing a lot of machines and a lot of power into it. So incentives are still on incentives and disincentives. So POS is particularly notable because it does not require the hardware stroke energy consumption required by PO proof of work networks. So like I said, anybody who has a lot of coins can be able to stake. So as you can see, this wallet has something more here. Has a lot of things. So you can participate in governance. You can submit a proposal. You can also track and see the rewarding system, track staking reward. So if you have staked, you can be able to see the staking rewards. You can also be able to exchange sell-off for other tokens. So you can exchange in between. You can also, you can do a lot. You can stake, you can vote for validators. So you can stake for validators. And let's see if we can be able to see more details about the validators. So these are all the validators within the Celo network and who they are. So you can be able to see the details of the validators. So these are people who have a lot of staking power. And as you can see, they are being voted for. So, and then they have rewards and the amount of Celo locked. So they have a lot of Celo locked. So like this one has 10,000. 10,305 Celos been locked for validation. So this one has, I think they are trying to get out of the staking process. They want to get out of the staking process. So they have zero stake. So you can be able to see, so they stand to lose this money. So these are a lot of money. If you have 30,000 sell all 10, let's do 10. Let's do 10 sell to USD. So right now, one Celo is $4.6. So if let's just do the conversion, like, so you have 10,000. 10,000. So you see the amount of money they will be losing. So this is a lot of money to lose just because of a transaction fee worth 10 Celos or 10 CUSD. That is $10. So you lose a lot. You lose a lot. Yeah. So it's a good way. It's a good way. It's a good way. And I think if such mechanism, if they are applied in sectors like music industry, whereby musician can be paid according to how many maybe album they have or something. I don't know. Yeah. So Yeah. Then proof of stake is particularly notable because it does not require a lot of hardware. So you don't require a lot of hardware. You just require that seller wallet, this seller wallet. So this is all you require to do the validation. So that's all you require to stake and do. Of course, you need a stable computer, a computer that is at least it has good. It's a good system. Yeah, it's a good laptop or something. Yeah. So then on POS network, there is significantly less consumption required. Further, proof of stake eliminates the barrier to entry of expensive computer hardware, instead placing priority on tokens locked up in the network. So POS also allows more users to participate in the creation of new blocks. So like I've shown you. So these are a lot of people who have participated, a lot of them who have been able to participate in the validation process. So these are a lot of people. So we have stake DAO. There are people who have 2 to 3 addresses, like 2 to 3 validators. They have a lot of, like this one has different nodes. They have different nodes, but they are the same. So this is 4. This is 4, MMS4, but it's the same person. It's the same person who has different nodes, and they have a lot of coins to stake. So in total, they have staked 40. Yeah, but it's the same. It's the same person. So it means that this person, the only thing they needed to have was more coins so that they can be able to stake. So anybody can be able to participate in the creation of the new blocks. But there is still a criticism of proof of stake methodology, is that the design actually favors the wealthy. So those who hold the most cryptocurrency, since it chooses validators with the most tokens stakes. So to combat this discrepancy, other methods of validator selection and iteration on the concept of staking have been developed, and the most being delegated proof of stake. So delegated proof of stake is actually interesting to see. There is a coin, Gitcoin. Bitcoin uses delegated delegation, uses delegated proof of stake. So they have different delegates, and they are labeled. Let me see. Things district, I think, yeah. So basically, this is how proof of work looks like. So we have the owner that stakes the token in a staking pool, and then we have a randomly selected validator, and then we have the selected validator proposes a block of transaction. Other validators verify and approve the transaction, and then the block is added to the existing blockchain. So the validator earns transaction fee, but they don't earn gas fee, because they don't earn mining fee, because all gas fee, they all gas price, because we have removed the mining part. So this is delegation machine. You can be able to delegate your coins to somebody. So there is more. You can explore this one if you are a developer. They have really awesome bounties. They do have bounties. They do have funds. They do have funds. You can get involved in DAOs. You can earn from learning. You can earn by building your knowledge. And apart from that, they go to the main page. Let me just sign up. Let me share the link on the chat. If you're a developer, you can study more. So they have bounties and hackathons that they are here. Yeah, hackathons, bounties, grants, quests, and for every quest you are able to earn. So there are different quests, and also there are different hackathons which you can participate for. And then they do crowdfunding for open source projects. So these are list of different hackathons which are available. And then there is a number of hackathons which have been completed already, which have been completed. So yeah. So it's interesting. This is how you earn something once you have been able to learn something new. Yeah. So that is how proof of work works. Now we can be able to move on to delegated proof of stake. So up to now, Emmanuel, we are now answering your question. So up to now, are we still moving towards space, towards moon? Or we have lost somebody else? So I think we are all in the same rocket. Okay, so delegated proof of stake, it's an upgrade of proof of stake concept, whereby users of the network vote and elect delegates to validate the next block. So delegates are also called witnesses or block producers. So using a delegated proof of stake, you can be able to vote on a delegate on delegates by pulling your tokens into a staking pool and linking those to a particular delegate. So like I had explained earlier, when it comes to shareholders and there are things that you want to pass, you combine your shareholding capacity, and that's where the concept of circles actually came to. So that's how the concept of circle, actually it's the same concept as circles, delegated proof of stake, because people come together all merry-go-round, women chamas. Women come together and they pull their tokens together, the money they have together, and that's how they are able to buy shamba. They are able to buy lands, they are able to buy companies, and they are able to do a lot. This is actually the same concept. So a lot of these things are actually things that we have been able to do like physically, like things which have been, so it's an aha effect. So delegates are chosen. So in those chamas or merry-go-rounds, they choose one woman who will be representing their needs when it comes to buying land, buying property, and everything. So delegates are chosen, all called witness or block producers, and they pull. You can vote on delegates by putting your tokens into a staking pool and linking those to a particular delegate. So you do not physically transfer your tokens to another wallet, but instead you utilize a staking service provider to stake your tokens in a staking pool. So a limited number of delegates, most protocol choose between 20 and 100. So they have to be between 20 and 100. I think Gitcoin had, let's see, under the organization. Community. So I can't remember the link that it was on the tab. I want to show you delegated proof of stake in governance. So you can choose a delegate. A delegate may be representing different. Okay, I think this one is. Yeah, this one. Okay, okay. Hope I'm gonna find it here. I wanted to show you like the different stewards, or in Gitcoin they call them stewards. Similarly to us, stewards of, we are stewards of Christ soul. Yeah, something. Yeah. So sure whether can remember. Okay, let's just pass. So they actually chose between 20 and 100 delegates. So and are chosen from each new block. So the delegate of one block might not be the delegate of the next block. So they are elected. So the first merry-go-round, the same for the women chamas. The first woman, or the first woman to actually win in the merry-go-round is not it's will for the next chama meeting will be a different woman, will be a different person. I mean, it will be a different person. So if we go for a merry-go-round, the next person who will be receiving cash will be different. So it cannot be the same person. It's the same case for delegated proof of stake. So any delegate who is going to create a new block, it's going to be a different delegate. So elected delegates receive the transaction fees from the validated blocks, and that reward is then shared with users who pooled their tokens in the successful delegated pool. So the same case. So for the women chama, the same women chama, when they buy property, everybody gets to have a share of the profit they make with the property they have bought. And if you are never part of that chama, and maybe you withdrew your stake from that chama, you are not given any reward. So it's the same case for delegated proof of stake. So the more you stake, the higher a share of the block reward you receive. The rewards are shared based on each user's stake. So if your stake if your stake represent 5% of the total staking balance, you should receive 5% of the stake of the block reward. So the same case, it doesn't mean because you have staked. The problem with women chamas is that there are some women who don't actually stake a lot of coins, but they still receive the same share. I don't know whether it's true. Somebody who is in a chama can share. So whatever you have staked is the reward that you're going to get. So there is no difference. The only difference between proof of stake and delegated proof of stake is that you elect somebody to actually represent, to create new blocks, and then since you don't have a lot of coins, you pull them together. That is the difference. But whatever you have pulled in that delegated proof of stake, that's what you're going to receive. So if you staked 10 coins, you're going to get a profit of that 10 coins. You're going to be given a profit of what you staked. Yeah. So that's on delegated proof of stake. And now we go to the hard part. So this one is a little bit hard for people. I don't know. Yeah, but it's a little bit hard. It's the benzenite general problem. So is there any question on the proof of stake and delegated proof of work before we dive into this one? I hope, Emmanuel, your question is answered.
Yes, you have answered it. Thanks.
Okay, awesome. Any question up to any other question up to now? Any question? So I'm gonna ask a question later on in the session, later on, like. So the benzenite generals problem is something which is interesting. And the reason why we are doing it is because I mentioned it on as the block under the core blockchain structure or the Zero protocol structure. Benzenite generals problem and subsequently gave rise to BFT, that is the benzenite fault tolerance. The concept of BFT has a promising relationship with the military tactics. In a scenario where different benzenite general gather around an enemy city before attacking it. So some of the notable highlights for the benzenite general problem is, which will be actually very helpful in understanding the benzenite fault tolerance consensus mechanism, is that the different benzenite general command their respective units at different position outside the city they are about to attack. So in the olden days, military used to, the military used to camp in different locations. So there was the first squad, the second one, and the third one. So the first squad was like a kilometer away, like 3 kilometers away from the position they are in right now. And then the other one, like that. So they were in desperate in different positions and locations. So, and different general has to command a unit. They have a unit to command. So they have to make sure that the attack is coordinated, so that if we say we want to attack, everybody goes in and attack. If we want to say we want to retreat, everybody retreats. So the coordination has to be there. And of course, there are generals who are not royal. So they will give different commands, so that yeah, that is the first problem. So they have to, generals have to command their respective units at different positions outside the city they are about to attack. So the generals can communicate with each other through messages, sending one message at a time. So you see, they have to also validate that the messenger brings in a varied information, a varied message. They have to have a way, they must validate the information the messenger is bringing, so that the messenger is not hijacked in between the 3 kilometers or 2 kilometers, is not hijacked and given the false information by the enemy. So the benzenite general must have coordination and agreement on a particular plan of action. So this is what I was saying, whether to attack or retreat successfully. So if all the generals attack at the same time, all of them retreat at the same time. Must retreat at the, if all the generals attack at the same time, all the generals, all of them retreat at the same time. So there is no problem. So if they decide to do the same action at the same time, and they agree that we want to attack and we go all in, but if we want to retreat, we retreat at the same time. there is no problem with that. But there raises a very bigger problem when one general retreats while others are attacking, or attacks where the others retreat. So it means that if the first general attack, it means that there will be bloodshed. But if these other ones retreat, the one general retreats, it means, but still we won't have a successful war, or a successful end game. So therefore the outcomes will be bad for all of the generals and their units. So the first person to attack, the first general to attack, it means he will lose a lot of soldiers. So another important point in the Benzenite general problem is that the fact that some of the generals are not loyal. So in the same case, the same scenario for these validators, it's the same concept. It's the same concept. So there are some people who just want to be validators, but they are not loyal to, or they won't be loyal to the system. So these generals could try sending the wrong or manipulated information to the other generals for confusing them. So this concept also works in networking of computers, the general networking of computers in a cyber cafe, or in an office, or in an organization. It works the same. You have to make sure that the network or the system does not fail. So the same concept is applied in blockchain. So you have to make sure that even if there are unloyal nodes which are not loyal in the blockchain, it means that the transactions have to go through. The transaction has to continue in the process. Yeah. So later on in the course of the year, I'll be introducing blockchain security and how we're gonna go deeper into blockchain security and how you can be able to prevent such things. The network, how the blockchain network really looks like, and such. So yeah, that's gonna be really interesting. It's gonna be a really interesting course, because yeah, this one is more on introductory, but if you want to become more in depth to learn more in depth about the Benzenite general and how it applies in terms of security and everything, yeah. So then we have now the practicality of it now. Sorry, yeah. So the practical benzenite fault tolerant, or PBFT, focuses on the state of the machine. So you can actually do more research on the benzenite general program and learn how they solve these particular problems. So this can be like your assignment. You can include it into the blog that you will be writing. So find like how did they, or how are these problems solved, or how are they able to solve them? Yeah. So on the message part, how do they validate that the messenger brings in the first unit? How do they validate that the first unit was never attacked or was never killed, and the messenger is bringing valid information from the unit they had? So it means that they will have to resend the messenger 2 times, or send another messenger to validate that the messenger went, yeah, that the messenger got the right message. But then the messenger, anyway, it's a tricky thing, yeah, but it helps in terms of coming up with a solution. Yeah. So on the practical benzenite fault tolerance, it actually focuses on the state of the machine. It replicates the system, but avoids the main benzenite's general problem. Now the question is how PBFT consensus work. So the algorithm assumes from the start that the network could have possible failure, and independent nodes might not work properly at certain times. So the PBFT is designed for synchronous consensus system and optimized in an efficient way to deal with the above issue. So in military, the same case, the general actually assumes that there will be possible failure in their mission, and they have to, and different soldiers may not work properly at certain times. So there are people who will be afraid that we are now in war zone, so they might freak out and maybe run away. So that's it. Moreover, all the nodes in the system are arranged in a particular order. So here there is an arrangement on how the nodes are particularly arranged, so that it makes sure that the most trusted and the most loyal nodes, I think they come first. The most loyal and those who have a lot of stake to lose. So out of all the nodes, one node acts as the primary node, while others work as the backup plan. However, all the nodes in the system perform their functions in harmony and interact with one another. So once you understand the basics of blockchain development, it is the time to understand the various tools that contribute to the blockchain development. So it's really interesting when you come to learning the consensus mechanism and proof of stake, because these are the fundamentals of the things that really makes the blockchain secure. Apart from cryptography, this is what also makes it even more secure. Yeah. So that's it on proof practical benzenite fault tolerant. Then we have other consensus mechanism. We have proof of capacity. We have proof of activity. We have proof of ban, proof of history, proof of elapsed time, proof of authority. If you have authority to access certain data, if you have the time that has elapsed, the proof of history, can you be able, like there is this other protocol called proof of humanity, something that was proposed by Vitalik. So currently there is no way to prove that a particular wallet address, it belongs to Jordan or it belongs to somebody. So Vitalik proposed coin webs of trust with reverse tuning test and dispute resolution to create a simple proof list of human. So it's kind of the not I'm human, not I'm not I'm a robot test. Yeah, or I'm not a robot test. Yeah. So I think I'm living in the alternate world where machines say they are not humans. So this is the Internet of Humans and the proof of humanity. So it's a consensus mechanism whereby you prove that you are a human. You are a human. So you are able to say that this wallet, I'm the one who owns it. I'm the one who owns it. Realize we are living with machines and humans and bots, and they can be able to mimic what humans can do. Yeah. So you just submit your profile, and humans who wish to be included in the agency submit information about themselves, serving for verification, and then they are able to collect UBI tokens. And yeah, so users can also challenge pending submissions that they think do not comply with the requirements for acceptance. So yeah. So that is on proof of sorry guys, my rights are out.